Hi everyone, this is Mrs. Eggerding and you are watching video 8 for Unit 6. We are going to talk about writing variation equations, which is a combination of stuff we've done from before, talking about rational expressions. First is direct variation, and we did direct variation a little bit first semester. And the words look like if y varies directly as x. And things with direct variation, these model a linear equation. Okay, so the model of direct variation is always going to be y equals k times x, where k acts as your slope or rate of change. And so when you see the words y varies directly as x, it's always y equals k times x. Now the second line here, you use this information to actually find that k. That k is called a constant, and you're going to plug in the 3 and the 10 to find your k value. Once you do that, then you can go down to the third line and find y when x equals 40. So y equals 3 over 10 times 40, and you do the arithmetic, and that's 12. So 3 parts. You have the variation equation, finding your value of k, and then finding the value that they ask you to. So what does direct variation look like? Direct variation is always going to give you a linear function through 0, 0. It will always be linear, and it will always pass through 0, 0. Second type is called inverse variation, and the formula for inverse variation is y equals k divided by x. And so when you see this, y varies inversely as x, first thing you write is k divided by x. The second line here, y equals 20 when x equals 1/4, you're going to use that to find that constant, to find that k. So if y equals 20, k divided by 1/4, you get rid of dividing by 1/4 by multiplying both sides by 1/4. And you get k to be 5. Once you find k, you can answer your question. So find y when x equals 20. It's going to be 5 over 20, and y is 1/4. Now, inverse variation, what does it look like? Well, since it is k divided by x, that's actually a rational expression, or it's a rational function. It has an asymptote at 0, and it will look just like a rational function would, with that curve going down. Inverse variation, what happens is as the x's get bigger, my y's get smaller. And that's what they mean by inverse. The bigger my x's get, the smaller my y's get. Now we can take direct and inverse variation and we can combine them with other statements, and this is called joint or a combined variation. So the phrase z varies jointly with x and y tells me that z is going to be some constant times x and y. So this is what the joint variation would look like. I still have my constant, and I have x times y. Again, the second part allows you to find your k value. So if z is 10, x is 3, y is 5, 3 times 5 is 15, and so 10 over 15 is k, which reduces very nicely to 2/3 for my k. And then the last part of the sentence, find z using my k and my x and my y. 7 times 5 is 35, times 2 is 70 over 3. So same process over and over, it's just these first words are going to determine what kind of expression you're going to use. One last example of joined and combined variations, I can start throwing in some other exponents. So this says, suppose A varies directly as the square of B and inversely as C. So I need to translate that. A varies directly as the square of B, means B squared, and inversely as C. So my variation equation looks like A equals K times B squared over C. The rest of the process is going to work similarly. They give you an A, B, and C that you will use to find your K. 4 squared over 10. Multiply both sides by 10 to get rid of the fraction. And that's going to get me 64 equals K times 16. Divide by 16 and I get K equals 4. So my variation equation is 4 times B squared over C. Use this last piece of information. 4 times 2 squared over 16. A is 4 times 4 over 16. So A will be 1 as your final answer. So every single one of these problems, same process. You use the words at the beginning to set up your variation equation. Afterwards should come some given information to help you find the K. And then the last part of the information, you'll use that K to find the value that you need. We're just going to do these straightforward. As we move forward in class, we're going to put them in a little bit more context. So questions 7 through 10 on page 373 just ask you to do some matching with graphs, and then 17 and 19 are some translating. There is an entrance slip for this, video 8. Bring any questions you have to class, and we'll work on some more of them later. Thanks. Bye-bye.